Welcome, dear student. Welcome to my channel Talking Physics with PR Sarkar. So, today we learn a very important chapter. A, the total mechanics is standing on this chapter. The chapter name is Laws of Motions. You already know that who is the proposer or who gives these laws of motions, the great scientist Isaac Newton. So we have already know from our little age that the three types of laws of motions, but here we do not discuss on the statement only. From till today we know about the only statement, that is every body continuous state of rest or motion unless it is acted upon by any external force to change its motions. Every particle, अगर कोई स्थिर पार्टिकल है, कोई पार्टिकल रेस्ट में है, तो वो रेस्ट में ही रहेगा, और कोई यूनिफॉर्म वेलोसिटी में मूव कर रहा है तो वो मूव भी करेगा इन along straight line path unless it is acted upon by any external force F equal to 0. But how can this be derived? So to know the history of laws of motions, we can go with 382 to 329 BC, which is the time of famous Dutch philosopher named Aristotle. You know Aristotle fallacy. What Aristotle said? Aristotle said that every body has a tendency to become in rest. If a body continues its motion, then after some times its speed is decreased and it becomes rest. So he said that unless acted upon by some external force, any particle cannot be moved uniformly or in state of motion. So according to Aristotle, the force is necessary. According to Aristotle, external force is necessary for uniform motion. Suppose if we push a ball or a toy, then we have to, if a boy pull a toy, suppose this is toy, then it continues its uniform motion as long as the boy pull the toy. But here he neglect a important fact that there is a force of friction arises which opposes the relative motion of particle. We know the property of friction is that it always oppose along the opposite to the applied force. So if the boy exert a force F external and the force of friction is F, then here F external must be greater than F to move the toy uniformly or in motion. So if there is absent of force of friction, then the external force is not needed. Only the external force is 0. Then only a particle will continue its motion. That is, if F equal to 0, then the acceleration must be 0. This is the main fact of Newton's first law. If F 0, then the body cannot be accelerated. And if F is non-zero, the body is accelerated. Now, how it can be derived? So, after failure of Aristotle's theory, a great scientist, you know the name, Galileo Galilei, was derived an experiment. He said that if a particle, then come Galileo. He's made an experiment in which he said that there are three cases. That if a particle is placed in an inclined plane and a ball, suppose a ball is placed in an inclined plane and an external force F is pushed the ball to upward direction, then its velocity becomes decreases with time. So it is retarded. Number two, the same ball is coming downward direction in an inclined plane, then its velocity increases with time and it is accelerate. But in horizontal plane, if the ball is taken in along horizontal, and in horizontal plane the particle moves in uniform velocity, moves in uniform velocity, that is no acceleration is occurred here. Okay, so अगर कोई भी चीज या वस्तु को इंक्लाइन प्लेन के बराबर हम लोग ऊपर लेना चाहे, ऊपर जाना चाहे, तो इसका रिटार्डेशन होता है. अगर वो प्लेन बराबर वो नीचे आता है तो वो एक्सीलरेट होता है. और अगर हॉरिजॉन्टल प्लेन, अलोंग हॉरिजॉन्टल प्लेन, its acceleration is 0 if external force is 0. Okay, if external force is 0. This property is known as, this property of particle is known as inertia. Inertia, the property of particle that a rest substance becomes rest, and a particle in motion with certain speed will continue its velocity or motion until it is not acted upon by any external force, is known as inertia. So Galileo gives the laws of inertia. Laws of inertia. Galileo, which says that if the external force is 0, the particle will move in uniform velocity, that is the velocity remains constant, does not change along straight line, unless it is compelled to be stopped or compelled to be changes state and becomes rest. Okay, so from this Sir Isaac Newton concluded his first law. What is this? Everybody continues, everybody continues its state. Everybody continues its state of rest or motion unless it is compelled by an external force to change its state of rest or uniform motion along straight line. This is the first law of Newton. Everybody continues its state of rest or motion unless it is compelled by an external force to change its state of rest or motion, uniform motion along straight line. So as long as F equal to 0, external force is 0, unless the body will be raised or it has some velocity u dash which becomes some finite value. Now the important point is, you know this from the class 7, 8 or from secondary examination, you know the law of Newton, okay? But here we know that what is the value of F or what is F. Here F does not mean that no force will acted on the particle. एक्सटर्नल फोर्स का मतलब कोई फोर्स पार्टिकल के ऊपर अप्लाई नहीं होता, इस ऐसा नहीं है. पार्टिकल के ऊपर फोर्स अप्लाई होगा, बट द algebraic sum, sorry, algebraic, I apologize, algebraic not, so the vector sum, as force is a vector quantity, so the vector sum of all forces must be 0. Okay, if a particle is placed on a table, then there are two force acted upon it. ऐसा नहीं कि इसका ऊपर a block of mass m is placed on a table and the total force acted on is 0, so it is raised. No, the particle A is placed on the table, so there are two force acting on it. The force due to gravity, we know W equal to mg. This is the force which is contactless force. Contactless force. You know the type of force. There are generally 4 type of forces. One is contactless force, like gravitational force, electromagnetic force. This is contactless force. One is contact force. Suppose a block is situated on a table, or 2 blocks are placed on the table like this. 2 block A, block 2, block A and block B are situated on a table and exert equal and opposite force to each other, which is called normal reaction. Okay, this is contact force. Contact force may be this type. Contact force may be the tension of a string. Contact force may be the spring force. Contact force may be the pulley force due to pulley. Okay, and the another 2 type of forces. One is one force which is very short range and within due to the nucleus, and it acts between only proton and neutron, which is known as nuclear force. And other is force is weak force. What is weak force? It is the force which acted upon between a proton, electron and neutron. When a neutron is transferred into a proton, then an electron and an antineutrino will be produced. And the reverse is when a proton is transferred into neutron, a neutrino and an antiparticle of electron, that is a positron, is produced. Such type of phenomena occur due to presence of force which is called weak force. So we do not we know only the name of this type of force. We do not elaborate them broadly or in brief. Okay, so here the block A is rest. The block A is rest means U equal to 0, and always there is a contact force. If the table is smooth, then a contact force between the common surface perpendicular to the common surface of table and block. This is the common surface, and a force perpendicular to it, this angle is 90 degree, perpendicular to it acts upon it, which is called normal reaction. This N is called normal reaction. Okay, so here as the block is rest, so it is said to be in equilibrium. अगर total force on a particle is 0, इसको कहते हैं वो particle equilibrium में है. So here the N must be equal to mg. N must be equal to mg, or N minus mg equal to 0. As the direction of their opposite, so one is plus, one is minus. So n minus mg equal to 0 or n equal to mg. So here two forces act, normally action and force due to gravity or weight. But the particle is at rest because the resultant or vector sum of the forces is 0. That means force may be act on a particle, but its resultant should be 0, so that the particle must be in equilibrium. That is, it is either at rest or moves with an uniform velocity. Again, we go with if there is friction present. In the previous picture, there is no friction between the block and the table, but here friction is present. Friction is present. Here friction is present. So what force apply on it? Here, if friction is present, then W is acted upon downward direction, and here the contact force has two components. One is perpendicular along the common surface. This is common surface. One is perpendicular of common surface, and one is parallel to the common surface. One is parallel to the common surface. So, and this force is known as frictional force. And friction and normal action must be perpendicular to each other. So, if we can say that the normal action is small n, so the total contact force N must be equal to n square plus f square. Okay. We draw another picture of two blocks. Picture of two blocks. Suppose A and B. Block A is upon block B, and the block A is, we do a very important numerical like to solve this. Suppose in an inclined plane, the 30° with horizontal, a block is placed in an inclined plane B, and the block A is moved towards F, and block B is moved towards right with a force F, and block B moved, you can say it F1, and block B moved towards left with a force F2. What forces are present here? The two blocks must be in equilibrium. That is, there is no acceleration between them or relative motion between them. So we know that if we take A and B, the diagram of A and B separately, then the weight of block B, that is WB, must be act along vertically downwards, and also the block of weight of block A, W, vertically downwards. Now, if A gives normal reaction to B, which is called N1, then B always gives a normal reaction to A, which is called N2. So, and the friction force, if A is moved towards right, then friction arises towards left, because this is the rule of friction. Friction always acting in opposite to the applied force, external applied force. For here, as B moved towards left, so the friction force act along this. So for block A, block A, we can get that this is a W and normal action due to B, that is N2, acted upon this, and the force F acted upon this along this, and also the force of friction F along this. So these four forces N2, W, F and F are acted upon A. So the A remains in equilibrium if N2 equal to W and applied force equal to frictional force. Clear हो रहा है? Now we go for block B. Block B, its weight WB vertically downwards. Now what is the normal action of A? Normal action of A, N1 along this, and the force of friction along, if the part F2 act along this, so force of friction opposite to it and perpendicular to N1. So this is the diagram of block B. N2 along this, WB along this, F along this, F2 along this. So this is the picture. We can draw N2 and F like this. There is W and N2. You can write it as the two forces W and N2 are along downwards. You can write it along this or draw it along this. Okay. Then it will be removed on this. Okay. So this is the main picture, that a force must be in equilibrium. So we draw a picture that suppose this is a wall and a weight 4 kg is hanging with the two string A and string B. String A makes an angle 60 degree with the wall. This is wall. The tension in string A is T1 and the tension in string B is T2. Find out T1 and T2 as it is in equilibrium. The block is in equilibrium. So what is the value of T1 and T2? Find T1 and T2. So from this picture, if we draw a parallel to this line, we can get as alternate angle 60 degree here. So T1 has two components along this, T1 cos 60 and perpendicular direction is T1 sin of 60. So for equilibrium we know that the total force must be 0. So as the total force must be 0, then T2 equal to T1 cos 60 and T1 sin 60 must be equal to mg, that is 4 into, we can take it 10 for convenient. So T1 equal to must be 40 divided by sin 60. So 40 divided by root 3 upon 2. So 80 by root 3 Newton. So T2 equal to T1 cos 60, that is half of T1. As the cos 60 value is half, T1 into half. So value of T1 is 80 by root 3 into half, that is 40 by root 3 Newton. So you can easily find out the value of T1 and T2. This is the diagram on mathematics. You can come out from Newton's laws of motion, first law. Okay, we remember that we cannot consider here any acceleration. In the next day we go with second law and we can solve our problem relating to acceleration and force. Okay, so now we can go with resolution of force. What is resolution of force? we know that the resolution of force is very important. Resolution of force is very important. If a block is situated in an inclined plane, then with 30 degree with horizontal, then its weight is acted upon this, and mg cos 30, as this angle must be 30 degree, so the normal direction along the opposite direction n. Along the plane, this is mg sin 30. So the perpendicular component of force, F perpendicular and F parallel. F perpendicular is mg cos 30, and F parallel, that is parallel to the inclined plane, is mg sin of 30. Okay. So for equilibrium force, if this is smooth, then mg sin 30 equal to 0, or if is friction acts along this, then mg sin 30 equal to F and n equal to mg cos 30. For equilibrium, the opposite forces are equal. Now for today we shall know the Newton's first law. कैसे न्यूटन्स का फर्स्ट लॉ आया है, व्हाट इज द concept of Newton's first law and equilibrium of forces related to Newton's first law. In the next day we shall go with, और हम लोग जानेंगे कि न्यूटन का सेकेंड लॉ और उसके न्यूमेरिकल के बारे में. अगर आपको मेरा वीडियो अच्छा लगा तो लाइक कर दीजिए, और अगर आपको ऐसी अच्छे वीडियो चाहिए तो सब्सक्राइब कर दीजिए. फॉर टुडे, थैंक यू वेरी मच.